This is integration packet number 18, problem number 7. I have gone ahead and given you the end results of 5 out of 6 of these problems, but I want to talk about D for a minute or two here. So I'm just going to rewrite it because it's a little hard to see, I think. So it's the integral of e to the x plus e to the 3x over e to the 2x dx. Now, if you go ahead and try different possibilities for you, and you could conceivably do that and probably would do that, you're going to find that you're not going to be able to find a perfect answer for what u would be and then to be able to substitute what du would be. So I make a recommendation in these kind of problems where you have two terms being added on a numerator and then one term below being in the denominator, that you go ahead and do a little separation of the fractions and then some division. And what I mean by that is if I take e to the x and divide it by 2x plus e to the 3x divided by e to the 2x, okay, we're up in the first term up here, we have combined the fractions that were actually in the second line. So I have gone about and decomposed those a bit and broken them up into partial fractions. So now if we do some division, all the terms have the same base, which is e. So if you have the same base, you just subtract your exponents. So the first term is going to become e to the negative x, and then the second term will be e to the x. So now the second term is the integral of e to the x. Well, hopefully that one's an easy one for you. That is just e to the x. We're always going to need a plus c, but we still need to figure out what the integral of e to the negative x is. So in part of your recommendations on how to find the integral of e to some other function is to try u to be whatever the exponent is. Okay? So in our case, u would be negative x. So our du would have to be negative dx. So really what I'm doing is trying to integrate the integral of e to the negative x dx. And so if I do my substitution, I would need to take, and in order to get dx, I need to make this a negative dx, which means I need to compensate with a negative sign outside. Then this negative dx becomes directly du, and the first part is e to the u. Now, just like the integral of e to the x is e to the x, which I've done over here, integral of e to the x is e to the x, the integral of e to the u is just e to the u, okay? And it's e to the u plus c. Now, if I go back to my original problem here, I had two terms to be integrated. So I have, sorry, I don't need the integral sign anymore. So I have e to the u plus e to the x plus c. Now I cannot, since my problem started off with the x variable, my answer needs to be in the x variable. So I can't have this u term right in here. I need to substitute back what u is, and what's u? U is this negative x, okay? So if I do that, my final result would be e to the negative x plus e to the x plus c.